Thank you, Bogdan. I think Bogdan did a great job. Okay. My name is Ali Pei. I work for J2 Global. At J2 Global, we do cloud services for small businesses. We have a bunch of fax, voice, email marketing, online storage, and those sort of services. Today, first I have a few or three trivia questions. And then I talk about OpenSIPS a little bit, and then cloud, what's cloud, and redundancy and high availability. Again, Bogdan asked this question. So how many people have already used OpenSIPS? Just raise your hands. And then just ask a simple question about OpenSIPS. If the answer is very simple to you, just hold on. Let other people try to answer the question. So let's say we have a bunch of phones, and then we have a bunch of FreeSWITCH servers. And then if a call, if one of the phones dials 4xxx, we want it to go to FreeSWITCH server 1. If it dials 5xxx, we want to go to FreeSWITCH number 2. What's the best way to do this? Or another way, how many ways we can do this? Go ahead.
You use dynamic route dispatchers.
Okay. Dynamic route and dispatcher?
Yeah.
How would you do with dispatcher?
I guess I don't understand the scope of the question.
So again, if the user on the set phone dials, let's say 4,000, we want to route, we get an invite, destination number is 4,000, we want to go to FreeSWITCH server number 1.
Oh.
If it dials 5,000, we want to go to FreeSWITCH number 2.
Right, so you have two dispatchers, one for each FreeSWITCH box, and you have a dynamic route that sends it to sorry, I'm getting 6,000 text messages. That sends it to the GR group, and I can remember the mapping, but basically we do it like rule, then group, then server, and then dispatcher.
Okay. Any other suggestion?
I mean, that's
how else can we do this?
I have a question. Do I have to stay in the path?
What's that?
Do I have to stay in the call? Or
No.
just forwarding the call to a FreeSWITCH server and getting rid of it?
Either or, yeah.
Then just do an analysis of the RURI and just forward it to whatever FreeSWITCH. That's easy.
Yeah, you can do that as well.
Yeah, to leave a room. I'm wondering if you can send the process up to
Again, yeah, there. So the point was here in OpenSIPS you can do same thing in many ways. Like our friends say here, you can just in your OpenSIPS.cfg, you can have some basic regex. You say if it's for whatever set destination host, go to this FreeSWITCH server, or if it's 5xx, go to the other solution. Or we can use dynamic routing. And then I'm sure you can use other ways to route to set your destination host. But if we hard-coded in our OpenSIPS CFG, many things can go wrong. But if you use dynamic routing module, for instance, then you get numerous features and nothing is hard-coded. If you change your rules, you don't need to restart your FreeSWITCH server, your OpenSIPS server, and so on. So we're going to talk about that a little bit more. Question number 2. So let's say it's a similar situation, but it's reversed. So we have a call coming from your carriers, and then you want to send it to different FreeSWITCH servers. How about this way? The other way, like the other direction. Again, you can use dynamic routing. In OpenSIPS, there is no such a thing as direction. An invite comes in, it's just a message that has come in. So you just basically in your OpenSIPS CFG, your routing script runs on any request that comes in. So one of the things that usually you would want to do in OpenSIPS, you want to detect your direction, because in your setup, in your environment, 90% or 99% of the time, you have the concept of direction. You want to handle the invites from different sources differently. So if it's coming from carriers, you want to do different things. If it's coming from your SIP phones, you would want to do different things. And if it's coming from your FreeSWITCH servers, you have a different logic. And then question number 3, what if we have both, like you have your SIP phones, you have your carriers. I already answered this one, which is, again, you would want to have some sort of concept, detect the direction, and then apply your logic for that invite. So if you get an invite message from your carriers, you say, okay, I need to apply these dynamic rules. You can have setup rules, and then you apply those setup rules, or you can have, you do your digit manipulation sort of thing. And if it's coming from your SIP phones, or you're from FreeSWITCH servers, or gateways, or Astra servers, then you apply those sort of things. So I'm going to talk a little bit about OpenSIPS. I'm going to try to stick to my 30 minutes. Otherwise, we're going to be here all night. And then after that, what's that?
You didn't bother voting.
So OpenSIPS. Best way to understand OpenSIPS is to understand the history of OpenSIPS. So OpenSIPS started in probably not 2005, but in maybe 1965, or I forgot the year, but when the first phone call was made. So as long as the telephony started, you needed a middleman. You always needed to have a gateway, something that sits in the middle and then does the routing. And that concept doesn't belong to telephony only. You have these middle devices, proxy servers, these gateways that sit in the middle in almost every industry. So like for IP, we have firewalls, routers, NATs that do the same thing, but at the IP level. For ISDN, like digital telephony, we have gateways that, these channels comes in and then it does routing to different servers or cards, T-bonds, and that kind of thing. Even for like water, electricity, we have like distribution panels. And then even like at airports, we have like transit. The functionality of that transit in an airport is the exact of OpenSIPS in a telephony environment. So the messages come in, you can do all sort of manipulation, security, apply your rules, do your checking, and then you route them out. That's the concept of OpenSIPS. So when it comes to VoIP or SIP, then we have OpenSIPS that does the same thing. So you receive all your requests, all your messaging, and you can do basically a stateless or stateful transmission of those calls. So so why would we want to have this proxy server in the middle? Improve performance. The calls come in, you can do load balancing, you can detect failure, you can do your authentication, you can do, it gives you a lot of flexibility. You can, again, like our examples, you can route based on your numbers, you can have, do manipulations, and then it does NAT for you, for instance. You can have redundancy and high availability. So it detects failure and reroutes. You can distribute the calls, and it can be distributed across multiple locations. So once you once you have all these things in your environment, then it actually gives you the ability to grow, be secure, and you know, proper handling of environment of your platform. And then again, you can do load balancing. So you have a bunch of servers that handles the calls, the registration. You know, it has a load balancer module that will take care of your traffic distribution. And then it can do your own scripting, rate limiting, you know, all sorts of features of OpenSIPS. And then why OpenSIPS? It's open source, no cost, no licensing fees, gives you flexibility because you have access. You can do your own routing, your own scripts, your own tables. You're not tied to a company. If you use a commercial proxy server, you're tied to that company. But open source, you know, if Bogdan gets hit by a bus today, we don't care. Tomorrow, someone else will take over. But if you're, let's say you use the logic goes under next year, you're toast. Your platform is based on the logic, you know. And then, so open source, there's a community, there's you know, wider support, and then also the future of telecom is open source. So again, talk about OpenSIPS just a little bit. Is it? So open source, OpenSIPS, you can do call routing, NAT traversal, it has registrar. I don't know why I have these slides again, talking about this. Performance, well, Bogdan just mentioned you can do 60,000 calls per second. In my environment, what scripts and things I do 1,000 calls per second, but that's far more than what you usually need. You can have distributed architecture. You can have multiple OpenSIPS servers that they can work together. There's over 130 modules, and there's lots of information out there. I listed a few of the modules that are often used in OpenSIPS, but I'm not going to go through these because most of you have already used OpenSIPS. But basically, you can do registration, authentication, you know, presence, and can be hooked up to databases for trunks or SIP trunks and routing. DR, we talked about dynamic routing, that prefix-based rules. You can assign priority, time, distribution. You can disable a trunk to go to drain mode. And and there are some utilities in OpenSIPS. You can get statistics, you can get SIP trace, capture your SIP traffic, flood detector, you can run scripts, counting, and that sort of thing. So after that, we're going to talk about cloud. So if you ever look up to the sky, there are always clouds. And I think that gave the idea to people to move everything to cloud. So clouds, they carry rain and thunderstorms, and sometimes there's the snow. They all come from clouds. Obviously, we're not talking about these sort of clouds. How many people here are from the States? How many from Canada? How many from Europe? Some Europeans. And South America? Okay. Anywhere else? Mexico. Oh, that's Central America. That's good. Anywhere else? Good. We have at least from 3 continents. So, what's cloud? The idea of cloud was it's somewhere. That's why they call it cloud. Because in IP, you can have, as long as you have a network connectivity or internet connectivity, it can be anywhere. And you don't know where it is. But if you have a cloud solution, it should be able to be somewhere and do the kind of work you wanted to do. And it could also be in multiple locations. The idea is that because it's somewhere, it's safer. Why? Because on those data centers, you have extra features that you wouldn't have in your own environment or in your own company. It's, you know, they have emergency power, it's monitored, it has better cooling systems, it's more secure, and then also because of these features, there's higher availability, and it usually provides redundancy. So in cloud solutions, you have redundant devices. Your firewalls, routers can be redundant. Your servers would be redundant. Your storage, and then you would have disaster recovery. So if there is an earthquake or fire, one data center goes down, you have other data centers that you can take over and have the same functionality. And it's also cheaper because you have a data centers that doing a whole bunch of platforms. So you're sharing the location, it makes it cheaper for everybody. But to have a cloud solution, you really need to be able to offer these services. So if one data center goes down, does your platform can move to another location and offer the same services? And that's what I'm going to talk about today. So basic network is that you know, you have a bunch of gateways, PBXs, you know, proxy server, you would have a database, you know, a bunch of SIP phones maybe on the internet, and or local to your subnet. You have carriers, SIP trunks, gateways, you know, maybe analog phones, analog PSTN, you know, or fax server, fax machines, and that kind of things. So is there? Sure, go ahead.
Could you stand right next to there because you...
I'm blocking
right in
it?
the middle, yeah.
Sorry, yeah. I blocked these guys a little bit.
No, if you stand right there, you're not going to block anyone.
Sounds good. So, how many people here, Bogdan asked this question, 10 minutes? Yeah, I've got the time. Yeah.
He's professional.
So Bogdan asked this question. So you guys already have OpenSIPS running in production, right? So is there anything that you're running in your production that is not in this diagram? Sure. Go ahead.
Well, maybe it's just a diagram, but usually you would have like sets of proxy servers.
Yes. No, that's my next diagram. Not in terms of redundancy, but just like in terms of, you know, devices.
Well, just for my scenario, I have separate gateways off to the side that give audio feedback from call route and call processing from the proxy. Your gateway is either PSTN or phones.
Those sort of PBX gateways. Well, I shouldn't have called them PBX, but like your, you know, Asterisk FreeSWITCH servers, your application servers, right?
Yeah, like mine give feedback, you know, like your account's negative, give us money.
Oh, like IVR servers.
Right, like sit-tone, tritone type stuff.
Yeah.
Which is just a separate chunk on the side that is indicated in that.
Actually, maybe
which doesn't really fall under PBX or the
Yeah.
databases you have in the file. That's just
You use what?
Redirect servers.
Oh, redirect servers. Oh, like that's OpenSIPS again?
Yeah.
Yeah. Video proxies. So the idea, yeah. And then how many people here do use OpenSet? Do you use database in your platform? Or let me simplify the question. Who doesn't use a database in your platform? So you always have a database. Or you don't have a database?
I'll talk about it.
Okay. And then how many people here, if your database goes down, your platform goes down? So
Should be everybody.
it should be.
Well, it's not set up redundantly, right? Is that what you're saying?
No, let's say your redundant database also goes down. Like your whole database
That's
goes
everybody
down.
in the room. Reasoning.
So, okay. So with redundancy, you would have, you would want to have redundant servers. But your cloud solution would look like something like this. So you would have a bunch of proxy OpenSIPS servers. You would have groups of your gateways. So your media gateways that, your IVR servers, you have a group of servers that do your IVR or maybe do your fax or you do your voice. And you have a database cluster, you have different carriers and different systems. So to make this be a cloud-ready solution or platform is that really your proxy your carriers. So this diagram can be distributed across multiple locations. So your group of servers, you can have one group in, let's say, California, another group in Texas, and then your proxy servers know about all these groups. And then if one location goes down, the call can get routed to another location. Also your carriers, so your proxy servers, you have a number of proxy servers that can also be distributed across different locations. So your carrier tries, let's say LA or California, and the whole data center is down. It can fail over to your next location. And then, your phones again can register to your primary registrar servers. If it goes down, they can go to the redundant location. And then, or some can be registered in California or East Coast, some can be West Coast, some can be registered to the East Coast, so you can do load distribution. And then, but in the bottleneck in this diagram, which is very common, is your database. So if your database goes down, then your whole platform will go down. And I just talk about quickly about how you have about 5 minutes, how you can avoid, how you can get around that you be independent on your independent of your database. And I'll talk about, so you can, that would be different, but for your OpenSIPS servers, all your configurations are in your database. Let's say you have a MySQL server running on your OpenSIPS servers. So first of all, you don't want to have anything hard-coded on your routing script, OpenSIPS.cfg. You want to have everything configured through your database. And then when OpenSIPS loads up, it loads everything in the memory. Let's say your dynamic routing module is all your rules and trunks and carriers and gateways are all configured in your DR table, and it's all in the memory. It's running off the memory. And then if you make changes to the database and you reload, so it reads the memory again. If your database goes down, your OpenSIPS is still running. So to be dependent of your database is that you would want to have some sort of cache DB running on each of your servers. So if you have a proper database design, the tables are used but for that server. So like for instance, if you have an IVR server that a call comes in, it needs to know what messages should play for that call. If that's cached locally, if your database goes down, that server is still running and it's doing what it's doing. It might be out of date. So let's say a user call comes in and the call should go to the voicemail. The user and your database goes down, it still sends the calls to the database, to the voicemail. But if the user goes and changes their routing rules and says, no, I don't want it to go to voicemail now, I want to play this message, you'll be out of date. Your server wouldn't know how to do that. But and then when your database comes back up, they all get updated. But your service is still running. And then on the other direction, let's say a call comes in and you have some information that you need to write to the database, like your CDRs or people calling and they punch in some keys to change some rules or do a routing differently. And for that, you need to have some sort of message bus implemented on your gateways or your on your application servers, that it all would get queued up, and then when the database comes back up, it will all be pushed down to the main database and will get replicated.
Well, but you have the same kind of failure, right? Then your message bus is down. It's the same thing.
What's that?
You just moved it back one, right?
No. Your message bus is running on this server. So if this server goes down, you have a redundant one will take over, right? So the message bus is running per application server. And all application servers are redundant of each other. So you have, let's say you do 10,000 simultaneous calls, you need 10 FreeSWITCH servers to handle those calls. These 10 are redundant of each other. So even if 3 of them go down, the other 7 are handling your calls.
Yeah,
It's like setting up RAID 6 on
but if your message bus is brokered, like RabbitMQ, if that's what you're describing, you're describing like AMPQ messaging. Like when you say message bus, what are you saying?
So cache DB, there are different ways you can do this. But let's say for CDR, as an example. So let's say these are FreeSWITCH servers. So when the call is finished, you record all the CDRs locally, and then every 2, 3, 4, 5 minutes, you read these and then you push them in your database. So if the database is down, they just get collected locally.
All right, guys. I understand that. I thought you were talking about like RabbitMQ or something. I'm like,
No, that's or let's say in a call queue or call center application, an agent logs in. Your database is down, so you put that in a table or somewhere locally, and then when the database comes, you update the set.
actually, that's my next question. What about stateful information? Because most of what you're talking about is kind of stateless. It doesn't matter. But things like agents being logged in, presence, prepaid accounts, all those things are stateful.
So present, like call queue, I only have 2 minutes, so I just quickly answer that question. So an agent comes online, you queue here, you say, you insert a row, say agent went online. 20 minutes later, it goes offline, you set it offline, and then when the database come online, you just apply those states, so eventually will get updated to the latest.
Okay.
So basically, you have a queue that you insert all those things. And then, and that's it. That was 29 minutes. I still have 1 minute left.
Don't look at me.
Based on my time.
That's this one, all right?
Yeah.
He keeps elbowing me. Get him off the stage.
Next year, we should put them at the end. Of the
I agree.
Last time slot.
This question. Okay.
Question. So, how many proxy servers do you have on your company?
Okay.
Are you using any load balancer?
Yeah, we do. So load balancing, where on run the proxy on the
Well, you
OpenSIP
put
server?
proxies, yeah.
Yes, yeah, we definitely use load balancer because we have, you know, you have group of servers and you want to do load balancing on those group of servers. Yeah.
OpenSIPS too?
Yeah, load balancer is a module in OpenSIPS.
Yeah,
Yeah.
we're using the same thing too, but
Yeah.
we don't have the tracks, we have the load balancer.
On the
Right after
carrier.
that, we have the gateways.
Oh,
We don't
okay.
have the proxy.
Yeah, but that's why you would want to have a proxy. Well, proxy is OpenSIPS, right?
Proxies, yeah, but we couldn't figure out the recommendation that, you know, I offered my company, I said like, okay, let's go with open source, OpenSet. Actually, they wanted to purchase Sonos session, you know, it's like they
SBC,
wanna,
yeah.
right. And I said like, let's go this, but I couldn't really figure out from the documentation.
You're at the right place. You can learn that.
Extremely difficult. I just figured out the load balancer, that's all.
Yeah, that's why you would want to come to OpenSIP Summit.
Yeah, women,
Yeah.
yeah.
Sure.
Are you doing anything like prepaid accounts where you need to share the state across multiple things? Are you using something like Memcache or Redis or something?
We don't do prepaid. You can actually ask that question from Flavio. But yeah.
Use Redis, okay. That works. All right.
We use Redis, Amazon Redis, but we don't need to really maintain Redis, just Amazon because it goes like
Okay, any other questions? Well, if you have any question, you can come and see me. I'll be here all day, actually all week. Yeah, for sure. Thank you.